Good evening, ladies and gentlemen. Welcome to the Western Branch evening presentation. Tonight we are grasping engineering very much by the core and talking about welding fumes and technology. Just a quick bit of history, and welding goes back to the Egyptians, and ever since then us as engineers have been forming methods to join various pieces of metal together. Tonight we have Hugh McPhillips with us, and Hugh's CV is as robust as the strongest welder any of us could do. 35 years as a lecturer at the College of West London teaching fabrication and welding, well-skilled UK judge and former training manager for construction metalwork, member of the professional board of the Welding Institute and president of the South Western Branch of TWI, and with that, author of 2 books on welding and fabrication. So we have an interesting presentation tonight. I'm going to hand over now to the presentation team, and Hugh, please educate us further.
Thank you very much, Mike, and welcome to all. I think it's important to say from the outset that if you're informed, then you can make fairly sound judgments. And one of the problems with safety in welding, whatever field you're in, is that you need to be reasonably informed of the hazards associated with the process. Could we go to the first slide, please? In terms of welding on the farm, this is probably a typical scenario. And whilst there is a lot of information there, we'll come back to that image later on in the program. You may be aware that a lot of the fumes associated with welding are covered by certain operating criteria, exposure limits and time-weighted averages. But steel, and we're talking about carbon steel, predominantly haven't fallen into that category. However, after serious research done by OSHA and the Health and Safety Executive, they have found that there has been a link between the manganese in carbon steels and its effect that it can have. So this directive has now come out that basically, regardless of whatever process you're doing in welding, if you're undertaking those activities on any metals, including mild steel, then you need to take appropriate protection. Now, there are different forms of protection available to you, and it's important to choose the most appropriate to suit the welding conditions. There's also evidence that's linked to kidney cancer and to some of the fumes that can come from some of the alloying elements that may be in the core of electrodes and in the wires, and also possibly from the parent materials. All businesses now come under this enforcement recommendation. They have to show means of controlling the exposure to welding fume. How this is done is dependent upon the nature of the business. Now, if we were talking about a fairly large workshop with a high vented roof, quite a considerable airflow through that with fans, etc. However, if you're working on work that's going to give a considerable amount of fume, then a local extraction unit being wheeled to the job is one of the most appropriate. And there are also now available respirable personal equipment, which is basically an air-fed mask. Before we talk about fume, we have to recognize that what we see is a cloud, and in that cloud is gaseous content and very, very fine particulate matter. That particulate can be ingested into the body and lodge in various organs and have a cumulative effect over a number of years. And one of the things that welding has often been associated with is that it has an effect on the lungs. Now, in the early days of welding, and we're talking now just after the Second World War, many welders were given milk as a bottle of milk as a way of trying to control any fume that they may have ingested. Fortunately, we've moved away from that. We've recognized that within the compounds and the compositions of the filler wires and the shielding gases, etc., there is a potential. And we now look to the scientists who give a feedback over a number of years of monitoring welders. The Americans have been doing this since the early 40s, and they've identified a number of issues. Cancer being one of those. Here, there's a direct link between hexavalent chromium, which is present in steel, stainless steels and nickel steels. Occupational asthma as another one, which could be associated with dense volumes of gases being given off, possibly when hard facing. Metal fume fever, often linked to the welding of galvanized materials, that's zinc coated materials. Irritation to throat and lungs, well, the composites and the compounds on stainless steel electrode coatings contain a percentage of acidic, and that acidic nature is what you're actually experiencing. Temporary reduced lung function, pneumonia, and in the long term, there could be some neurological. This is where the manganism is starting to come in. This has been in the States since the early 40s. They've been monitoring this, and it can give a condition somewhat similar, long-term, we're talking, long-term exposure to a possible condition similar to Parkinson's disease. So we need to be aware. If we're aware, we can make judgments. As I said, there is two parts to any fume. One is the respiratory, and the other is the inhalation. And on the right-hand side, top right, you can see an X-ray of the lungs scarred, and you can also see the shadowing effects on the lower part. On the left, bottom left, we've got someone doing TIG welding, which would be considered a relatively low fume process. And on the right-hand side, we have a manual metal arc weld going in, which could be considered to be on the highest fume level. And see, in the groups below, you can fall within those categories using whatever processes you're currently using. When we look at consumables, we're predominantly talking about iron, chromium, nickel, manganese would be in there, could be titanium, there could be niobium, there could be molybdenum. Some of this will vaporize by the very nature of the art you create and the amount of gap that you give between the end of your electrode and the workpiece. If you're operating at very high currents, higher than you need to, and perhaps using a CO2 gas instead of an argon CO2 gas, you can produce considerable spatter. When we look at the gases, nitrous oxide, which you are more familiar with possibly as a laughing gas, but it has an effect on the bodily functions. Ozone, which is given off from the radiation naturally in the radiation of the arc, but also from welding aluminium. You'll get far more ozone coming when you work in that particular material. Carbon monoxide coming from the arc processes. Cellulosic electrodes have certain ingredients in them to intensify the arc. And what that does is it also releases a considerable more content of carbon monoxide. Also, the other thing that you need to be aware of is that how you store your consumables. If they get damp, then they can fire and they can create more carbon monoxide whilst they're drying out, as it were. Here we have an example of working stainless steel, hexavalent chromium content, where this is the issue with this potential for a carcinogenic substance. If we go with a conventional manual metal arc electrode, then there's an 87% percentage on that particular process. If we move to flux core wires, it reduces down to 50%. If we go to a solid wire MIG, we're down to 16%. So if we're looking at working on stainless steels and we're looking at, say, mass production, then obviously the solid wire mag would be the better option to choose, speed-wise, etc. TIG is another option to look at there. Again, that would be within that range. But you can see that just by choosing the appropriate welding process, you can reduce the effect that you are making welders having to work in that environment. So you need to be always looking at the most appropriate process to try and reduce. Now, in effect, whilst you see this gas or cloud or shield, as it is termed, within that there are certain elements, nitrogen dioxide, collectively known as the nitrous gases. They are generated by the oxidation of nitrogen in the air from the effects of the arc or the flame. So oxyacetylene is not one of those that doesn't fall in this category as well. Carbon monoxide, it could be generated by the flux welding processes. Also, of course, lots of shielding gases for the MIG-MAGS process may have a carbon monoxide content with it. And also when they undergoing reactions in the vicinity of the arc to form carbon monoxide. And it's the carbon monoxide that gives you the effects of feeling dizzy and lightheaded. So for instance, if you were to perhaps carry out a repair, or perhaps you would want to replace a panel in the boot of a car. You've got your head in there. You're using an argon CO2 mixture. Perhaps the doors of the garage are shut. You're putting that, you're in a vicinity of an enclosed vessel almost. You're putting a weld in with a gas which is invisible, which you won't smell, but the effects could be that you could collapse, and unless someone was to get you out, it could be fatal. So at all times, when working with the MAGS process, make sure that you've got through ventilation at all times. If there is any instance where that may not be possible, then you should be monitored by someone else all the time, so that if they notice it, you feel it getting drowsy, etc., they can take the appropriate action. Be very wary of shielding gases. Make sure that you have the appropriate extraction and the appropriate ventilation to the air. Things that we do at home, we may not necessarily do at work or somewhere else, but we need to be wary that these gases exist and they can be catastrophic. Ozone can be generated with it by the reaction of the ultraviolet light, arc and oxygen in the air generated. But it also decays quickly upon arc extinction. There are organic materials such as shock primers, organic coatings, adhesives, sealants, oils. These can all generate some fume, although there have been some developments now whereby you can get well-through primers. These have taken into account the potential for the fume, and they've reduced the content and they've increased the conductivity of the coating. So for people working classic car restoration or whatever, they may well prime it and then they can still weld onto that coating. We often use trichloroethylene and chlorinated solvents as degreasants. Now, these can accumulate in very small pockets in the whatever we're making. So it's very important to ensure that they fully evaporate off. As a young apprentice myself, and that's hard to believe looking at me now, I used trichloroethylene almost like I would use washing up liquid. I was putting it all over sheets, degreasing, using cloths all over the place. The people that I worked with, they all smoked. And what they didn't realize is that through that filter in the cigarette and the combination of that heat with the fume, they were actually taking fossil gas into their lungs, which is the First World War mustard gas. Now, this you will be able to smell very rapidly because it smells a bit like freshly mown grass. So if you get that smell, stop working immediately and check to see if there's any pocket in which some degreasant may still be present. Make sure it has fully evaporated off before you carry out any welding operation or any application of heat. Now, because of the range of materials that you, especially with regards to agriculture and across a whole range of industries, we come across a lot of coatings now on materials. They're there to prevent corrosions. They may be there for electrical conductivity. They may have a number of applications. So it's important to know the potential risks working with those materials. All of the cadmium coated surfaces are resistant to mold and bacteria. So you can see that it lends itself to mass production. Many of you will have come across nuts and bolts and little brackets and stuff like that have all got this almost like a rainbow effect. It's a sort of goldy color, and that is a cadmium coat. It provides resistance to corrosion. It's also forms a little bit of a barrier when it's in contact with aluminium, so you don't get the decay that you might get with aluminium. It's a great lubricant, and it's got low electrical contact resistance. It has a high toxicity and can be fatal in high concentrations when welding. So if you're going to put something onto a cadmium coated plate, the area where the weld is going to be carried out must be ground clean of the cadmium coat, and it should have a clearance area sufficient for the process that you're using. So that if you're using something like a MIG or TIG process, at least 12 mil all round the area where you're going to be welding, so that that doesn't progress. You need to be aware of the heat buildup because the conductivity could give some problems, but generally that should be okay. But again, local extraction wherever possible. Cadmium has been associated with lung diseases such as emphysema, as well as kidney failure. Cadmium was at one time a constituent of many soft solders. That has been taken out because of the very nature of this material. It's been a long-term hazard in terms of ingestion and inhalation, and there is a time-weighted allowance on the exposure to that material. So in that instance, I would advocate not only local extraction, but definitely an air-fed mask with that particular material. Increasingly, aluminium is being used as a surface coating. It bonds well with the carbon steel, and it gives it excellent sort of corrosion resistance, almost in the sacral. It has a low thermal coefficient expansion, so that it has an advantage over stainless steel. When it is welded, some of the particles could actually produce light fume, which consists almost entirely of magnesium oxide and aluminium oxide, which are known to be lung irritants. The deposits are responsible for alumininosis, also known as aluminium lung and bronchitis. These should be avoided as much as possible. However, a short-term exposure shouldn't adversely affect long-term health effects, unlike fumes produced when welding other materials. Typical application of an aluminized coating now is on exhaust. So if a bracket breaks off and you need to put that bracket on, clean the area around that area where you're going to put in that weld. And again, work on those sort of margins of clearance. You can get a cold aluminized paint that you can put on after the repair has been carried out, ensure that you get back that corrosion resistance. But any aluminized coatings, when you start to heat up, if it's not running properly, the tendency could well be that it is aluminized coating. Our old favorite, the one that's been around for a number of years, has massive applications all around. Virtually everything in the farm industry has got a galvanized coating on it somewhere. And it's here where people carry out repairs and they don't realize that that white cloud, that billowing that's coming off of the material, is actually zinc oxide fumes that they could inhale. Metal fume fever. This is something that some welders will, at some stage, flu-like symptoms with nausea, headaches, high fever, shivers, and thirst. Sometimes you can even get the taste of metal on your mouth, on your lips. You can taste it. So you just need to be very, very wary. Here, if you want to do some repair on that, advocate the use of a brass or a bronze material, because it will alloy with the zinc. You won't need to take off the zinc coating. It will alloy with the zinc because the brass is a copper zinc alloy, and you will find that it will give you the flexibility and strength, especially in things gates, etc., where there is a potential for fatigue. Preferable to weld out of doors, again using local extraction to prevent the fume buildup. And it is vital, and this is going out now to the young people that are learning, that the weld is well trained. You must ensure that you keep your welding shield and your welder's face out of the plume of fumes that come off a welded joint. So learn to stand to one side of it so that you can view the weld and the plumes to the side. your local extraction will be coming in between you and the source of the fume. Okay. Nickel coated coatings have increasingly come in, especially we start looking at pressurized systems, and we're looking at pumping, and we're looking at in the agricultural and in the food industries. These coatings are excellent. Corrosion resistance very high, very in terms of they don't impart anything to them. So increasingly they're being used. There are over 3,000 alloys of nickel which are used in industries and processes. However, when inhaled as a vapor, nickel carbonyl can produce immediate or delayed lung damage, and it can also have an effect on the nervous system. So we're talking about a long-term exposure here. Inhaling air containing nickel or compounds may cause occupational asthma. This is why I come back to my example with the stainless steel electrodes. You will smell that irritant straight away. So make sure in that instance you have, I would suggest, an air-fed mask when working those types of materials. Breathing in air containing certain nickel compounds over long periods raises concerns about cancer. Hexavalent chromium and nickel are within the category of the health and safety and OSHA guidelines, and they are being continuously monitored. So be aware of them. And finally, any activities which require special attention when assessing exposure, welding and hot cutting of stainless steels. So if you use a powder cutting process on the stainless steels, again, there's a considerable amount of fume that comes off of that process, so be very wary. Chromium coating, again, in many respects, this is one for the aesthetic look of the product, and also to give it excellent corrosion resistance. But again, we've got the hexavalent chromium, and again, any hot work, there's a potential for that hexavalent chromium to be released. Therefore, it's recommended practice to ensure that you have good local extraction, ventilation, and respiratory equipment as well. I apologize for all of these coatings, but I think you need to be aware, because these materials are increasingly going across a range of industries, and at some stage you may well across these. Manganese, quite often all new cars have a manganese coating on it so that they give the corrosion resistance, and they give an excellent key for the paint coat to go onto. So all of the things that when you start looking at repairing a car, you're aware that the base coat on that steel may well have a manganese content within it. Also, gears, power transmission systems, critical parts, nuts, bolts, etc., all got this manganese coating put on them. It's a relatively cheap, very easy to adhere to the material, but it has the potential to cause this condition known as manganism long term. So again, grind off the area, carry out the repair, then you can get phosphate spray coatings back on, which will cover and bring back the corrosion resistance that you require. Some of the symptoms of manganese and Parkinson's disease are similar. It causes tremors, shaking, loss of muscle control. And these conditions can become more as time goes on. The Health and Safety Executive now recognise that manganese can also be carcinogenic, and therefore it now recommends that local exhaust for ventilation and a respiratory protection equipment be used at all times when welding carbon steels. And inhaled manganese over a long period can have adverse health effects, including damage to the lungs, kidneys, and there is a potential for a higher risk of infertility in case of male workers, something that we're not necessarily looking for when we put a weld in. Now, with any product and any the machinery that we're working with, we need to be aware that there may be a residue on the equipment that we're going to carry out that repair. And ammonia is one of the possibilities because of the range of muck spreading and other things that goes on. Again, a potential. We are more than aware of the fumes that can come from that, but also when you couple that with the other gases that could be coming off, there's a possibility that we could have an explosive reaction, or certainly some form of combustible activity. Fertilizers, very high in nitrates. So again, we've got lots of situations here. Nitrogen introduced to a weld will produce a very hard surface, which will bring about the failure of the weld. And also it can have an explosive effect, as has been proved with some of the bombs, homemade bombs, etc., that have been made. So again, what we're looking for here is to, wherever we're going at that repair, make sure it's scrupulously clean and possibly use a solvent to clean down that area prior to welding, so that we ensure that we've got a chemically clean surface that we're going to put the weld onto, and that we don't have any lingering alternative ingredients. Now we come to the control measures, and perhaps one that's a little bit has caused a lot of people a lot of anxiety. Risk assessments, when they first came out, were the bane of every working man, because we didn't really understand what it was about. Today, I would say a risk assessment has become a tool in the armory of everyone working with industry. One, it provides some guidance on and recognition of the operation that we're about to carry out. It identifies the hazards. It gives us, we put in place the measures to limit the effect of those. It leaves the opportunity to choose alternative joining processes, which might reduce the level considerably. And it also recognizes the fact that we have others in the area that could be affected by the effects of welding, whether that be visible light, whether it be fume, whether it could be an explosion or whatever. The risk assessment for the welder in many ways is their first line of insurance, because in effect, if the risk assessment is drawn up correctly, you have taken every single step possible to produce or to carry out an activity that is practically possible. In effect, you need to be able to operate that equipment within that level. To date, it can no longer be the case that ignorance is bliss. There is too much information out there for you to be able to argue that case in court. A risk assessment done, carried out in accordance with the guidelines, gives you your first line of defense. Real safety data sheets available with every product that is produced and put onto the market will have all of the hazards associated with using that material. Choice and modification of the welding process, and this is where it comes down to ensuring that you have a good knowledge of the range of processes that are available to you, the advantages and disadvantages of using that equipment, which is the safest, whether you use AC or DC, so you've got the opportunity. Improvement in working practices has come by a lot of research that has been done off the back of those initial risk assessments. They've identified where the dangers are, and they've brought into being a whole raft of safe working practices. Ventilation has become critical as we now have so many people operating within that engineering environment, and the effects do go out to all persons, whether you're just the person welding, or even if you're just the person walking through that area delivering a package or whatever. And certainly if you're out on site, you need to be aware that you may have personnel come into that area while you're welding. So you need to cordon off that area. You need to put signs up to say that no entry, welding being out. Use of respiratory protection equipment. Again, this is made an excellent case, because where there are situations where you cannot get a mobile extraction unit into that particular area. If I go inside a very tight vessel, if I get a bit of kit in there, I can't move. But with a mask on, I can work. However, if I'm going to do that, then it's essential that a lifeline is attached to the individual working in that environment. And the thumb, one tug, are you okay? 2 tugs, fine. So that needs to go on, because in some cases, if people were to try to use walkie-talkies, it wouldn't work because of the cage effect of the surrounding material. So air-fed mouse and a rope, we're looking at trying to take the danger down to minimum levels. And use of on-torch extraction. These have been in existence for quite some time with the MIG and MAGS torches, but they are now also being developed for TIG weld as well. So again, it's a great initiative that's being taken. We're taking the fume at source and extracting it. Here we have some examples of a mobile local extraction unit on the left-hand side. This would have a filter in it, and the idea is it will take the fume through the filter, arrest the particulate matter, clear the air, and release the surplus air. Great in terms of being maneuverability, and again, but you need to be aware that those filters need regularly changing, and some may be electrostatic, which means that they'll trap it and then there'll be a demagnetizing effect, and it'll drop into a collection box, and that'll be changed that way. The respiratory mask, as we said, again, in a situation where working in a confined space or low car scenario, you've got that sort of ability to work fairly close to it. And the on-gun extraction, you can see that there's very little fume emanating from that particular process. I'll just take a point to just go back to the first drawing or first picture. On the left-hand side, it's very important that you notice the of the cowl of the extraction unit between the source of fume and the welder, not above him, but between him. So you're extracting it at source. Now, those will also have, in those arms will be dampers, and those dampers can be regulated to give the minimum transport velocity, but be very effective. What we have to be guarded about here is that there is a potential for us to extract the gas to a point where we are allowing oxidation of the weld. So we're sucking away the protective shield. You need to have a minimum transport velocity so you can maintain that shielding of the weld, and at the same time you can take away the fume from it. And that is something that you need to be aware of if you're working out on site, because if there are high winds, they may well take away your shield, whether you're using a manual metal arc, which has got, when you strike the arc, you create your own shield. But if the wind is, it can take that away, and you can get atmospheric contamination of your weld deposit. So you may need to erect some temporary shielding around you to give you some, like a wind brace or that type of scenario. So again, something to think about. Sometimes you may not be able to get sufficient control with a local extraction alone. And if there is a case that it's seen that the capture, you'd be able to get all of the fume, then any residual fume could be controlled by the use of these disposable masks. And you're very much familiar with these, because these are quite often the ones that were recommended for the staff dealing with COVID. But again, they have a duration period with them. They have a maximum protection factor, and they also give a good range of protection. The one thing that they do require is a close fitting. Now, if you happen to have a beard or something of that nature, or rough shaven, you need to ensure that you make sure that you get a very tight fit around the area there, so that they are effective. You don't want any parts where it can seep through. And you need to also ensure that you're shielding to protect other workers from any eye damage. It's quite a common thing that when you first learn to weld, you get used to shouting eyes. So always give whoever may be in the area the signal that you're about to commence welding. Therefore, they have the opportunity to take the appropriate action. But you should have shielding there, and it should be some form of. And one other thing that I might add here, when you work on aluminium or stainless steel, it will radiate light all over the place. So it's good practice to have some fire blankets and cover the area that is not going to be welded, so that that reduces the amount of light that is emanating from the area where you're welding. Also bear in mind that many workshops are painted white in order to give the maximum effect in the workshop, but white surfaces will radiate light and they will bounce around a workshop. Now, our eyes are trained to react to an instantaneous light coming at us from the front. They don't necessarily react to the periphery light that comes in the side, and it's that can do the damage to some people's vision. So be very wary of carrying out any welding activities. Always assess the area before you go into it. I'm very aware that we're getting tight on time, so I'm going to move a little bit quicker. Obviously, the directive outlines the exposure limits, and important that you ensure that all the equipment, if it's faulty, repair it straight away. Every day looking for signs of damage. All operatives should be trained to look for that damage prior to work. Don't get on the job, check your equipment before you start, because once you've started, it may be too late. It's good practice to get a competent ventilation engineer to come in and thoroughly test and examine the equipment. And the recommendation, at least every 14 months. What they should have is a report telling you the effectiveness of the filtering system, the transport velocities will be tested, and it should give you a report and certification to state that that is meeting the RICS or the current requirements. Make sure that you keep all your records up to date, because with the Health and Safety Directive now, it could be that they could call in upon you at any stage, and always review the controls. Anything was to change in the layout of the workshop or the functions that you carry out. So the recommendations are that there should be some sort of respiratory health surveillance carried out on people, especially if they work with stainless steels, for the possibility that they may develop asthma. Individual health records being kept, records and dates when you worked on jobs. So again, this is where the litigation could possibly come in. Advice from competent persons such as occupational health providers. And in the last bit, as an employer, if you choose to do this, then it's your responsibility to maintain health records. But what we're talking about basically is putting it onto a computer, put the statistics in there, and it's relatively easy to do. It's recommended to keep for at least 40 years. Electrical safety, it's always to be working outside to choose the equipment. Always I would recommend the use of a DC plant, because you have a lower open circuit voltage. When you strike an arc, the open circuit voltage on AC can be 1.4 times the mean voltage. So if it was 100, you could be up at 140 volts at a peak. Whereas if you're on DC, it's around about 40 to 60 volts. So there's a lower potential at all times. Always check all the cables, all of the connections. Recommendation to wear rubber sole shoes at all times. Make sure you don't leave any electrical tools on the workbenches that you're going to strike up on, because you provide an alternative electrical path, and always work within the capacity of the machine. These are some of the symbols that you may come across. On the top left-hand side is the plate that would be on most modern welders, and on there will be an insulation value, which will give you an indication of the potential for working out of doors. You'll see at the bottom left-hand side, we've got people working around water with electrical plant. So again, in this instance, I would recommend that all of the equipment be plugged into a safety device, which basically trips out the welding current down to a minimum 30 volts. And when you strike the arc or whatever, it will give you the full voltage back up. The one on the top right, we have someone working inside a vessel. Again, as I said, fed mask, insulation where he's at, might touch the side of the vessel, etc. And again, a lifeline at all times. This was a directive that came out from Europe, and it's one that's not that well known, but basically it was recognizing that whenever we use electricity, there is a magnetic flux that is generated, and that magnetic flux can have an effect on the body. And therefore, you need to be aware that when working with electrical cables, whatever, there is this potential for magnetic flux. Anyone who has one of the pacemakers fitted should never be around electrical arc welding process, because it will change the rhythm of the device. Here's some examples of some welding issues that I thought might reflect on. In the left-hand picture, we have someone going to carry out a repair. Now, the first thing that strikes me is one of, it's really a pressure directive, because we have pneumatic and hydraulic hoses going to the equipment. There's an area there working. It's obviously got the situation where it's a structural application as well, because it's going to be lifting a load. And anyone carrying out that repair should be working to a weld procedure and a repair procedure, that type of work, because the consequences of something going wrong on that could bring about potential manslaughter charges long term. So we need to look at all the implications of carrying out these sort of repairs. In the top right, we have some hard facing a bucket. Sorry, we've gone. Can you go back, Miles? That's it. We've got someone hard facing a bucket. So hard facing quite often uses cobalt, manganese, and other materials which give off considerable fume. So although in outdoors, I would still recommend that he should wear an air-fed mask. Also, I'll draw your attention to the fact of his apparel, or what he's wearing. He's got his arms open to the rays. So ultraviolet radiation will give him skin burns. If he was working like that for any period of time, he could find he ends up with skin cancer. You need to protect the body at all times from ultraviolet and infrared radiation. In the bottom left, we have a gentleman carrying out a weld. You can see that there is some hot slag dropping down, and very close by is a tire, which I would imagine is got a very high pressure in it, which could cause considerable damage if it blew out. So that area there should be covered, a fire blanket at all times. Also, the welding plant moved back a little bit, and I would recommend that he should have leather protection on there because of the hot sparks that are coming off. In the instance on the bottom right, which was our original shot, you'll see that the gentleman is carrying out hot slag dropping down onto very tinder grass. He could find that he completes the weld and ends up completely surrounded by a field of fire. So that's an initiative there. Also, you'll notice that there's another very substantial behind him, which could get some hot slag onto it, burn through. Again, there's a possibility there. There are pneumatics up there as well, and also it's a structural application. As a regard, all welding repairs should be documented, outlining procedures adopted. If any preheat or post-heat has been used, the weld sequence, any machining. Documentation should form part of a quality assurance program that supports good working practice, and any repair needs to comply with the regulations governing the maintenance and the safe use of the equipment. And it is recommended that it should also be inspected by an independent third party.
Hugh,
yes.
Thank you very much, Hugh. Have we? We've completed a very informative talk, and I'm sure that we've got some questions already in the chat there. Just looking at the questions we've got there. Are people happy to unmute themselves and ask? If we go to the first one there, Richard Robinson, do you want to unmute yourself, Richard?
Yeah. Sorry, I'm just remembering which question I asked. Can I start with my last one first?
Yeah, well.
Which was when you're welding on equipment with batteries, what's your view about disconnecting batteries or alternators when you're welding?
I would always disconnect because the potential for a hydrogen build-up and an explosion. Also, I think it's important to remember that a lot of the agricultural equipment now has sophisticated electronic components and computers on board, and ideally the earthing strap should be disconnected to ensure that you don't send a current through that equipment. So you might have carried out an effective repair, but it's going to cost you best part of 10 grand to get the computer system back up and operating. So be very wary, and that cars as well.
Thanks, Richard. Just moving on to Nick. Do you want to unmute, Nick?
Yep. Thank you, Hugh, for a very informative talk. Early in your presentation, you mentioned that there's been some recent legislation and recent work carried out into looking at the fumes from mild steel. I just wondered how recent that was, Hugh.
It's been ongoing for a long time. It initially stems, as I say, from America, but the Health and Safety Executive have been monitoring it for the last 5 years. They've come to this decision that it's now recognised, and also with their partners in Europe as well. So it's a European-wide directive as well. So I think it was on the cards. I think we've got to a point now with litigation that you need to be seen to have explored all the avenues and all of the potentials. And I think that's where they're coming from. They want to make sure that they've put out a directive that covers virtually all materials.
Yeah, thank you.
Thanks, Nick. Just moving on to Rupert, please.
Hi there, Hugh. Yeah, thanks for the really interesting talk. It's a long time since I've done any welding, but one thing I remembered, and I was going to ask this question, but then you got onto it in your third slide on coatings, was about, I was always told to, you know, the risks of welding galvanized steel.
Yeah.
So my question was, and you did get onto it on the later slide, is that a lot of materials have a material safety data sheet, which I've come across for chemicals and oils before, but I didn't necessarily know there was for metal parts. But a manufacturer might have access to that, but not necessarily Farmer Giles. Or is there some way that, you know,
yes,
you could see, oh, what's that sort of coating? Is it nickel? Is it aluminium? Is it, you know, and what should I do?
Right. In some cases, you can carry out some simple tests. One could be a scribe test, where you scribe the surface. If it's a relatively soft material surface coating, it may be just an aluminized coating. If it's very hard and dense, it could be a chromium coat. Obviously, it is difficult, and what I would possibly recommend is that you lightly cling back to base metal for an area that you're going in the immediate area that you're going to be welding, and then you can get various products on the market which lay on cold spray to restore that protective coating.
Yeah. So,
and also bear in mind that the Health and Safety Executive have got information sheets on all of these materials currently on the market, and they will give you lots of information, free to click on and download any information that you require.
oh, okay. Yeah, that's worth knowing. Yeah, thank you.
Thanks, Rupert. We're back to Richard again.
Yeah, I can perhaps cover two in one go now. But you mentioned using a brass filler rod on galvanized material.
Yeah, braze weld it, or you can now there are MIG wires that have a brass composition in.
Yeah, I'm just thinking most of the time when if you're welding galvanized, you're generally an outside occupation.
Yeah, if you're outside, what I'd do is I'd grind it back. I'd use a mild steel material, and then what I'd do is have a can of spray cold galvanized and put 2 to 3 layers on after the weld is sufficiently cooled.
Okay, fine, that makes sense.
Yep.
Hugh, I've got a question for you. We often try and solve problems at source. Is there any way that in the future, the way that welding consumables are designed, that fumes could be reduced?
I think what you will find that really all the manufacturers, if you were to take the consensus of what their fume content was, say 20 years ago, and look at their current products, they've reduced considerably the fume generated off those products. And a lot of them will make a key point in their marketing that they produce the lowest fume concentration. So from that point of view, you're on all the marketing material, that somewhere there'll be some mention about the fume content. There'll be information that steers you towards what the composite of that core material is as well. So that'll give you an indication as well of the type of material that you're depositing. And also it'll indicate the temperature at which it goes in, which can be critical to how much fume is generated. Bear in mind, if we increase the amperage and the voltage of the process, then we also increase the generation of the fume. So if we can get materials that work at a lower amperage, the amount of fume generated will be considerably reduced.
Thanks very much, Hugh. It seems as though as a city and guilds welding craft and practice for many years ago, there's quite often going back to some of those basic principles alongside obviously the fume control, but those areas of getting a good weld, cleanliness, and understanding what you're wanting to achieve at the end of it. There was the planning and preparation delivers results.
I think you could say that about most things. As you say, the planning is cool, and if you can assess the situation, look at is there fume / fire potential? What are your actions that you're going to take should anything occur? You have to have that plan in place. Certainly, if you're working on some materials that be combustible, a good example would be an aluminium magnesium alloy. If anyone plunges that into water, it will go up like a fireball. Magnesium with water will create a fireball. So be very wary. Even ribbons or the grindings of aluminium magnesium materials, if stored, can accumulate. And if any moisture gets to it, you could have a fire on your hands. So if you understand your materials, if you store your materials and your tools well, if you maintain your equipment, you keep up to date with the latest recommendations in terms of safety and other things, and monitor at all times. Never assume, always be wary. And I think that's probably the way to forward. Whenever I tackle any job, I look to what space I've got, what area I've got to move around in. I'm always wary of the light being generated, the fume being generated, and where I'm putting my consumables, spent consumables. So for instance, a stub off the electrode, where am I putting it? I don't want to be putting it anywhere near flammable materials. And always make sure that you're buttoned up, head shield on, gloves, gauntlets, protect the arms. It may be hot, but you don't burn that you can get off ultraviolet.
So no, and I think we understand, and there's certainly some clear messages there. I think we've probably completed the questions, Hugh, and we've certainly enjoyed the discussions, and the knowledge of your the welding areas, etc., and your experience is certainly a subject matter that we could tap into again.
Yeah, by all means.
And with the range of members of the audience that we've got here and their experience. So I think if there's no more questions, we'd like to pass on our thanks to you and to Miles, and you're very much welcome to obviously we'll obviously keep you updated on what the Western Branch are doing.
As I say, Mike, if anyone has any queries that they can't think of necessarily now, you've got my email address. By all means, people can contact me. And as I say, I've been talking with Mike about possibly a collaboration between the Institute of Agriculture and ourselves. So hopefully we can go forward with sharing best practice and knowledge across the Southwest.